So today we're going over chapter 10, section 1, lines and segments that intersect circles. I want to point out this chapter, this lesson has a lot of vocab. So make sure you're following along to what each thing means so you're not lost as we're going. So we have circles. Circles are a set of all points in a plane that are equidistant from a given point in that plane. The center is that given point. The radius is a segment whose endpoints are the center and any point on the circle. And the plural of radius is radii. So if you guys have a circle, you guys have this circle. I just drew it here. You have different points. The point right here at the middle, that is the center. Now, the line, I'm going to do it in different colors. In red, right here, it's a straight line, or the straightest I can make it. That is the radius, or R for now. And the points that are equidistant from the center are all the points at the edge of the circle. So this black line right here, all of those points are equidistant from the center. So the radius is going to be the same everywhere as long as it goes from the center to the edge. So the radius, just so you guys have it, it's center to edge. That's always going to be the case. So now we have the chord, the secant, the diameter, and the tangent. So the chord is a segment whose endpoints are on a circle. Those points are edge to edge. The diameter is a chord that contains the center of the circle. So diameter is just another chord, but the key is that it crosses through the center, so that it has the center. That's the whole difference between a chord and a diameter. A secant is a line that intersects a circle at 2 points. So this time it's a line, so it's going to keep going on forever. And a tangent line is a line in the plane of a circle that intersects a circle in exactly 1 point, called the point of tangency. Now, if we have a circle, the point of tangency, let's say it's right here. It's a line that only touches that circle at that 1 point. So we have the radius inside, a chord through here. I'm going to do it in red for the diameter. The diameter could be right here. As long as it crosses through the middle is a diameter. And we have the tangent. Now, if I were to draw the secant as well so you guys have it, the secant, I'm just going to cross it through here. It's a line, so I'm going to put arrows on it. So we have the chord, which is in black, the diameter, which is in red, the secant, which is in blue, and the tangent, which is in black outside. And the point of tangency is this point right here. So I'm going to write that as point of tangency. So now we have a picture of the chord, secant, diameter, and tangent, so what we drew before. I just want to notice or point out that the secant is out of the circle because it's a line. It doesn't stop at the edge. That's why when I drew it as well, I drew the line with arrows on it. So we have example 1. Point O is the center of the circle, and they want us to name each figure. Now, it is important that they stated that O is the center, because that means that we can go based on the center to realize what each thing is. Now, OM is right here. So that is from the center to the edge, so that's the radius because it touches the center, but it's only half. MN is this whole segment right here, and it stops right at the edge. I just accidentally drew a little longer, so that's going to be a chord. And then we have right here line MN, but because you have the line already up top of it, you know it's going to be a secant. But if you see it, you notice how it keeps going outside of the circle. So I'm going to erase this right now and then keep highlighting. Now MQ is right here. It crosses from edge to edge and it crosses through the center. So that is a diameter. Now ML is this point or this segment right here. That is a tangent segment because it's just a segment, so and then we have line ML. Line is the whole line that's going through it. So that's going to be tangent line. And then they tell us point M. Point M is right here. That is the point of tangency. So now we have common internal versus common external tangent lines. So if you draw a segment connecting the centers of the circles, if the segment intersects the common tangent, then the tangent is internal. If it doesn't, then the tangent is external. So the tangent lines are the lines that are already drawn for us. So this is a common tangent. So let's draw it. So if we draw a line from the center to the center, it doesn't cross it. So the lines don't cross each other. So this is a common external tangent. Now let's do the same thing for the other one. We draw the lines in the center. We draw the line in between the center points. And we notice how they cross. Because the line intersects, this line is connecting the circles. So this is a common internal tangent. We have congruent and concentric circles. Congruent circles are circles that have congruent radii, and concentric circles are circles that lie in the same plane and have the same center. So I'm going to try to draw the congruent circles. Might not look the best. So we have a circle like this. And if we have a circle like this, I'm trying to draw it kind of 3D, but it might not pop up how I want it to, like that. Let's pretend that's a circle kind of crossing each other. Those are not concentric, they're not in the same plane, but they would be congruent because they have the same radii. Now, concentric circles, which in this case is this one, they lie on the same plane. So you see we have the outer edge of one circle and the outer edge of the other, and they share this same center. It kind of looks like a bullseye. This is a very common example. So a bullseye example. For the concentric circle. Now the bullseye is the most common way you're going to see a concentric circle because they're in the same plane. I'm going to write on the other one not concentric so you guys have it as well. I said it, but I didn't write it down. They're not concentric, they're not in the same plane. For the left one, they would be congruent even though they're on the same plane just because they have the same radii. And then the other one is concentric because they have the same center and they're on the same plane. But they will not be congruent because they don't have the same radius. Now we have tangent circles, coplanar circles that are tangent to the same line at the same point. Now for this, all you really have to know or notice is that these tangent circles are going to touch only at one point, and it's going to be at that point of tangency. Now they can be like this, that the line is shared and the two circles are outside, or there can be like this, where the two circles are on the same plate, kind of stacked on top of each other, but they still share that same tangent point. That's all that's really it for it. So now we have theorem 10.1 is, in a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at the point of tangency. So what does this mean? What are the key words? Only if. It's really, really important here. Because the only way you can tell that this line is tangent is if this is at a 90-degree angle. So if BC is tangent to circle A, then AB is perpendicular to BC. So if and only if, you guys remember this type of statement, we saw them at the first semester. But the key part right here is that it's a perpendicular to the radius. It's the only way that that line can be tangent. Now we have theorem 10.2 is the tangent segment from a common external point are congruent. So it's saying AB equals to BC. You guys can think of this as an ice cream cone, I guess. It's a good way of thinking about it. Or a snow cone. So because these two lines are tangent, they're only going to touch at one point of the circle, and they're going to meet at the same place. If they are congruent, like they're stating, so they're going to be equal to each other, then they're going to be the same distance, and they're going to be tangent to the circle in the same place. So you can think of it as an ice cream cone or a snow cone, as it holds whatever that circle flavor thing you want, whether it be ice cream or snow cone, in the same place, because it's going to be tangent and only touching it at one point. And so it has to be equal on both sides. Here we have example 2. If OR is equal to 6, so I'm going to fill in right here 6. OT is equal to 8, so this one right here. What is RT? Now, because this is the radius, we know OT is going to be tangent because that's what we've been learning, right? We know that this is going to be a 90-degree angle, so we can actually use Pythagorean theorem to solve this. So it's going 6 squared plus 8 squared is equal to, I'm going to call this C squared instead of RT just to make it easier. So it's going to be 36 plus 64 is equal to C squared. That's going to be 100 is equal to C squared. When I take the square root, I end up with 10 is equal to C. So RT is equal to 10. So like I said, I am going to erase this so I can go ahead and do part B. I am going to refill the answer for the first one so you guys have it. So 10. So for part B, they're telling us angle ORT, so ORT, this one right here, is 45. And they're telling us OT is 4. They want us to find out what RT is. Now, because we know this is a tangent line, we know that's going to be a 90. Obviously, that is not drawn to scale. So this is going to be a 45, 45, 90 degree, which is a special triangle. If you guys remember, the 45, 45, 90 is A root 2. So because we have one of the A's, which in this case they gave us right here, the 4, I can say RT is just going to be 4 root 2. That is one way you could do it. Now, if you happen to forget that this is a special right triangle, or you remember it's a special right triangle, but you don't remember how it works, you know that this is also going to be 4. So you can do 4 squared plus 4 squared equals C squared, and then do 16 plus 16 equals C squared, 32 equals C squared. I'm going to take the square root from both sides, And then the 32 is going to simplify into 2 and 16, 4 and 4. So it's going to be 4 root 2 is equal to C. So we end up with the same thing. It's just shorter if you notice or remember that it is a special triangle. All right, so example 3, the first one. Name a line tangent to circle P, but not to circle O. Now, just so you guys know, this is circle O and this is circle P. So a line that is tangent to circle P, but not tangent to circle O would be line, for example, BO. Or you can call it OB. Why is that one not tangent to O, but yes to P? It's tangent right here, and then it goes to the center of O, so it doesn't overlap. Now for B, they want us to name a common external tangent to circle O and circle P. So if you guys remember how to do the external, I'm going to draw from the circle of both and figure out which line doesn't touch that is tangent to both circles. In this case, a line that doesn't touch and is tangent to both circles is line CD. And then we have C is named the common internal tangent to circle O and circle P. Remember, the internal tangent is the one that crosses, but it's tangent to both. So in this case, it would be line AE. Again, remember you can call it EA. If you did, that's fine. Or for 2, if you called it DC, that's fine too. I just wanted to write one or the other. Either one would be fine. So, example 4, circle M and circle N are tangent at P. So they're both tangent right here. It says PR and SR are tangent to circle N, so the big circle. And circle N has a diameter of 16. Because we know it has a diameter of 16, I'm just going to go ahead and draw it. So it's going to be 16. That's actually probably the worst color I could have chosen. 16, they're telling us PQ, so this segment right here is 3. And they're telling us RQ is 12. Awesome. They're telling us to find PM. Now, PM is this segment right here. But to find PM, I want you to realize that is the radius of the big circle. And the radius of the big circle is half of the diameter. So, since the diameter is 16, the radius is going to be 4. And that radius is actually the diameter of this small circle. PM is the radius of the small circle. So, I'm going to have to divide it. Sorry, I meant to write 8. I did it in my head ahead of time. So I'm going to have to go ahead and divide that 8 by 2 to get PM, which is the radius. So that would be 4. Now, we want to find MQ, which is this segment right here. And for that, we're going to need to do the Pythagorean theorem. Keep in mind, they're telling us our tangent. And we have this triangle right here. We have 3, 4, and we're going to have to solve for the diameter. Now, if you guys remember, this is one of those special triplets, so it's going to be a 3, 4, 5 triangle. But if you don't remember, you can use the Pythagorean theorem. Let me just write triple so you guys remember. You could do 4 squared plus 3 squared equals C squared. 16 plus 9 equals C squared. That's going to be 25 equals C squared. When I take the square root, I get that 5 is equal to C. So you can always do the Pythagorean theorem if you don't remember that that is a triple. Now they're asking for PR. PR is this whole segment, so I'm just going to go ahead and add 12 plus 3 to give me 15. That's how I got PR is equal to 15. Now SR, they want us to solve it, but if you guys remember from the snow cone slide, those two segments are going to be the same since we know they are tangent because it is given to us in the instructions, so they're both 15. Now, NS is this segment right here, or, well, better drawn like that. Now that is the radius of the big circle, and as we know the radius is half of the diameter, so we can do 16 divided by 2, and that's how we get that is 8. I'll write that information down, and then they're asking for NR, which is this segment right here. Again, you're going to have this triangle, 90 degree, 8, 15, I'm going to say c squared. This is another triple. So this is an 8, 15, 17 triangle. I'm going to write triple so you guys have it. But again, if you don't remember, you can do a squared plus 15 squared equals c squared. And you should be able to find that the hypotenuse is 17. Now, these two, I'm just going to write the information. So there's two tangents. Same endpoint. The triples I wrote down. Remember that the radius is half of the diameter. And remember the diameter, like in other words, is twice the radius. Remember, you need to know the vocabulary because there's a lot of it and it gets confusing if you don't know segment, chords, radius, diameters, endpoints, tangents, center. It's going to get a bit confusing. So let's go over example 5. It says point B is a point of tangency and find the radius r of a circle C. Now, because this is the right triangle, I can use a Pythagorean theorem. So I'm going to say r squared plus 24 squared equals r plus 16 squared. Now, why do I write it like that and not just 16? Because this whole triangle is the right triangle. And also because we have r right here, which is part of the segment, and the other r, which is the other part of the segment. Now, the only part that is honestly going to take a little bit is the foiling. You get r squared plus 24 squared. 24 squared is 576 equals, I'm just going to write r plus 16, r plus 16, and then I'm going to go ahead and start foiling. So r squared plus 576 equals r squared plus 16r plus 16r plus 16 times 16 is 256. So I'm going to get r squared plus 576 equals r squared plus 32r plus 256. I'm going to go ahead and start combining by subtracting r squared. They happen to cancel each other, which is perfect. 576 equals 32r plus 256. I'm going to subtract 256 from both sides. So 576 minus 256 is going to equal 320. So 320 equals 32r. I'm going to divide by 32 on both sides. And then that's going to leave me with r equaling 10. So our radius is 10. So if we have example 6, it says point B is a point of tangency. So that means we have a 90-degree angle from the radius. They want us to find the radius r of circle C. Now this is just like the last example. And we have to set it up as r squared plus 14 squared equals r plus 7 squared. It's going to be r squared. Now 14 squared is 196. And I'm just going to rewrite this as r plus 7 times r plus 7, as we're going to have to FOIL it to solve it. So then we get r squared plus 196 equals r squared plus 7r plus 7r plus 49. So it's going to become r squared plus 196 equals r squared plus 14r plus 49. I subtract r squared from both sides. They happen to cancel out. So we're left with 196 equals 14r plus 49. I'm going to subtract 49 from both sides. And I get that 196 minus 49 is 147. So 147 is equal to 14r. Then I divide by 14 on both sides. And I get that my r, which is the radius, is equal to 10.5. Now I plugged it in the calculator, and that's why I got a decimal. If you would have kept it as a fraction, you would have gotten 10(1/2). But I'm solving it right now with the calculator, so that's how I got the fraction. Sorry, the decimal. So example 7 is point M and N are points of tangency. Find the value of x. So if you remember, if these two are point of tangencies and the N have the same endpoint, they are congruent. So I can just go ahead and do x squared is equal to 9. Take the square root and get x is equal either plus or minus 3. But because you can't have a negative distance, this is just going to be the positive answer, so we're just going to get x is equal to 3. Example 8, it says point B and D are points of tangency. Find the values of x. So now we have the same thing. These two lines are going to be congruent. So I'm just going to go ahead and do 2x squared plus 2x is equal to 7x plus 12. I'm going to go ahead and subtract 7x from both sides to get 2x squared minus 5x is equal to 12. I'm going to subtract 12 from both sides, and I'm going to get 2x squared minus 5x minus 12 is equal to 0. The reason I put it equal to 0 is to factor it out. I'm going to try to factor it. Now the factors of 12. If you guys factor differently, that's fine. There's nothing wrong with it. Just, I might have learned it a different way. But as long as you get the same answer, it's all good. Okay, pretty sure it's going to be these two. 8, 3. Okay. So we get these two factors equal to 0. Now we're going to get two x's. The first x I'm going to equal one parentheses, so I'm going to get 2x plus 3 is equal to 0. 2x is equal to negative 3. X is equal to negative 3/2. And then for the second parentheses, x minus 4 is equal to 0. So we get x is equal to 4. So we have two x's. One x is negative 3/2, and the other one is 4. These are your answers for this problem. All right, since we finished the notes, you guys have homework on Canvas. It is due by the first day after the break. But that's it for today's notes.